Hey everybody. So in this video we are going to be solving trigonometric equations. So the problem says solve 3 sine squared x minus 14 sine x plus 8 equals 0 for all solutions 0 is less than or equal to x, which is less than 2 pi. Now this boundary pretty much means that we're only looking at values on the unit circle. Now one thing that may be really easy here to solve this equation is to replace sine x with just the variable x. So let's do that. When we say 3x squared minus 14x plus 8, this looks like a quadratic, which these are pretty easy to solve. So when you're solving quadratics and your a variable is greater than 1, or excuse me, your a coefficient is greater than 1, we solve by using the AC method. So we're going to take 3 and 8 and we're going to multiply them together, and that's going to give us 24. Now, we're going to look at the factors of 24, and we will stop looking for factors of 24 when we find two numbers that will combine to give us 14. So 1 times 24 gives us 24, but we cannot add or subtract 1 and 24 in order to get 14. So we'll look at the next set of factors. That's 2 and 12. If we add 2 and 12, that gives us 14. Now, we need to multiply these two together to get positive 24, and when we add them, we get negative 14. So that means both variables, or excuse me, both numbers should be negative. Now, the negative 2 and the negative 12 are just going to replace the 14x here. So this will look like a polynomial. It'll have 4 terms. The 3x squared and the 8 come down, and instead of negative 14x, I write negative 2x minus 12x. The reason I do this is because with 4 terms, I can now factor by grouping. So I could pair the first 2 terms together and the last 2. What I'll do now is I'll look at the first binomial and I'll factor out the greatest common factor, which would be x. And then out of the second group, I could pull out the greatest common factor of negative 4. So the binomial that's the same will factor out 3x minus 2, and then what remains, x minus 4, will be my second binomial. Now we know from algebra the way we solve here with our binomials is we set each one equal to 0. So we'll say 3x minus 2 is 0 and x minus 4 is 0. So when we solve for x, we get 2/3 and we get positive 4. Now, the problem did not want us to find the solution when x equals 0, rather when sine of x equals 0. So since we've solved for x here, what we'll do is we'll replace each x with sine of x. So that gives us sine of x is 2/3 and sine of x is 4. Now, here, if I wanted x by itself, I need to undo this sign. And the way we undo sine is to multiply by its inverse. So that would give us the inverse sine of 2/3 and the inverse sine of 4. So remember that because my domain is listed in radians here, that means that my calculator should also be in radians. So when I do the inverse sine of 2/3, that's going to give me 0.73 radians. And when I do the inverse sine of positive 4, the calculator is going to give me an error. So we know that inverse sine only has solutions in quadrants 1 and 4. This means that there is no value out of these two quadrants that I could substitute in to get a value of 4 here. So I'll only look at 0.73 radians. Out of the unit circle, I need to determine what quadrant would 0.73 radians be in. Would that be in quadrant 1? Would that be in quadrant 2, 3, or 4? 0.73 radians is going to be in quadrant 1. Because here, this is pi over 2. If I wrote this as a decimal, that would be 3.14 divided by 2, which is approximately 1.5. So 0.73 is in between 0 and 1.5. So this is the quadrant that it's in. The reason I do it here is because we know that sine inverse is only going to give solutions in the first and fourth quadrant. But in the unit circle, since I'm looking at all possible values, is there another radian value that would have the same y value as 0.73 radians? And that answer is yes, because radians that have the same y value are on the same horizontal line. So if I move this over here to quadrant 2, these two radians would have the exact same y value. Now we got 0.73 radians in quadrant 1 because we started at 0 and went up 0.73 radians. The way we find the radian value here is we're going to subtract it from pi. So we're going to say pi minus 0.73 radians, and that's going to give us 2.41 radians. So when it says solve for all solutions, my two solutions are going to be 2.41 radians and 0.73 radians. All right, that's going to be it for this video. I hope that you found it helpful. If you have any questions, please make sure you leave them in the comments, and we'll see you all in the next video.